And hello, everybody. Welcome to a special edition of Ask an Engineer. This one is CircuitPython Day edition.
Ask an Engineers. We're going to have a whole range of engineers here,
right.
from hardware to firmware to software to documentation to everything in between, and talking about what we're doing here with CircuitPython. This is a magical day, 9/9, the snakiest day, and 8 o'clock, which is a snaky time as well, very round. And we're going to just check in with everybody.
And then theoretically, we're also celebrating the latest release. CircuitPython 6 is the poster. You can see this. We'll be asking some of the folks on the stream tonight about what's new in CircuitPython 6 and more. And I'll bubble up some questions from the chat.
Yeah.
And Discord, adafruit.ic/Discord. So let's start to bring our team in. We've got Kathy, Ann, Dan, Scott, Kepler, Alan, Melissa, and Brian. All right. So this
Hollywood Squares.
Yeah, this week, normally, we do our show with very presentation style.
Yeah.
But Python is code plus community. Kind of came up with that slogan, that word, that tag. So I thought I'd start off in no particular order. I'll call on each of you. Maybe just talk about a couple sentences about who you are and what you work on in the world of CircuitPython. So I'm going to start with Katni, because she's the square right over here.
Yeah, it's backwards. I spent our live stream pointing the wrong direction.
Yeah, that's fine. You're over there.
Got it.
Top center square. All right, Kenny. Well, you just introduce yourself, but
yeah.
All right.
What do you do?
So I'm Katni. I work with CircuitPython in lots of ways. I oversee all of the CircuitPython libraries and coordinate everything involved with those. I've had the opportunity to write a couple libraries. As well, I've done projects that usually end up in guides. So that's been a lot of fun. And I've designed a few CircuitPython compatible breakout boards. In fact, they have my name on them. So you'll know if you have a Katni board. And a lot of documentation stuff, a lot of background stuff, kind of a lot of things.
Okay. A lot of things.
All right. And what I'm going to do throughout the show is, if you have questions, I'm going to store them off to the side, and we'll get to them. First, we'll do intros, and then I'll sprinkle some questions in between. So we'll do a little bit of each, some intros, and then some topics, and then we'll jump over to some questions. Next up, Ann, who are you, what you do, and what do you do at CircuitPython?
Hello. I'm an engineer who does a number of things for Adafruit and the CircuitPython team. Katni mentioned guides. The Adafruit Learning System has over 2,000 guides. I'm the primary moderator before they go to Lady Ada for final. I look them over. I've authored a few dozen guides myself. I also do a lot of the writing and technical writing, the social media writing for CircuitPython Native Fruit team. I'm currently doing the editing on the Python for Microcontrollers newsletter.
Celebrating 99 this week, so we could claim we timed it that way because CircuitPython Day is 9/9, just happened to work out that way. But next week is the 100th Python on Hardware newsletter.
It is.
All right.
Incredible.
Okay, next up, Jepler. What's up to?
Hi.
Python, what do you do?
Well, I'm the new guy, so I do whatever they tell me to do. But I just love getting to work in all of the parts, mostly in the core, but I've dabbled a little bit in the libraries. And yeah, just give me something new and exciting to learn about next time is the way I would prefer to do things.
Yeah, you've done a lot. You've done the Sharp Memory Display IO add-on that was recently. I think you worked on
MP3s,
MP3 decoding. You added.
Yeah.
Yeah, we just saw a project on Show and Tell. MP3 is a big deal because one, it's out of patent. Two, everyone has them. Everything can export to it, and that means microcontrollers finally have music.
Yeah, and now you're working on CAN bus. So you're actually kind of working on all the things that are the icing on top, right? Of the circuit.
Sure.
Things that people really wanted for a long time, and we haven't been able to do, and you're able to go in and just sweep them all up.
Yeah, and I'm doing things I didn't imagine I would do, like appear live on YouTube with everyone watching me. So that's a lot of fun too.
Don't worry, nobody can see you here.
Okay, that's a relief.
This is very private.
I think when you build a community and you build something that's really special, it's really easy to do these things because you know the people involved. You see the projects out there. There is a community of folks. Everyone's helpful and looking out for each other, and you know the subject matter so well. So I think like live streaming, a lot of times people try to do it, but they're not as interested in the subject matter. They're told go do that, and they're like, oh man, I'm like, I don't know. What if they ask a question? But this is like what we do every single hour. In fact, we do a weekly, we call it creative engineering chat. But at 6 p.m. we do a chat all together, and it feels a lot like this. In fact, it looks a lot like this.
It does.
Go around like, what are we working on? And I'm always like, oh man, like too bad we can't broadcast that. So this is like maybe the first step towards that. We may as well broadcast it all.
Yeah, it's a lot of fun to feel connected to this community in a way I haven't in my other jobs, just because they're people I identify with instead of people who are just users, right?
Yeah. Yeah, you can see a lot of the work that you do, like the code you publish, you'll see someone come along like Liz, for instance, and show a project, like that's the code you just finished, you just published. That's neat.
Yeah, and she's not some faceless client of a client of a client. It's like
exactly.
She's there.
The client wants the logo bigger.
And she's showing you like, okay, I'm doing this MIDI thing and it's triggering, double trigger, why, and you'll figure it out.
Yeah.
All right. Sure. And we didn't plan this way, but Center Square, Scott, the lead developer, engineer, and
Everyone point at Scott.
And Center Square. Scott, what do you do and what are you up to at CircuitPython?
I think you gave me a decent introduction. My name is Scott. I was the first person that Adafruit hired to explore MicroPython on the SAMD21, which is a lot of the boards that Adafruit produced. So I'm kind of the OG developer on what became CircuitPython. If you have questions about why it's CircuitPython, you can blame me for part of that. We can have those discussions.
No, it's a community decision.
Yeah. It was more than just me, for sure. And so right now, kind of like I try to lead the project, giving us kind of a long-term vision to what we're doing, and how that fits into what Adafruit's doing on the hardware side. And then I spend a non-trivial amount of time trying to get more people ramped up into the project, into the community, both on the core side, which is where I work most of the time, but also on the library side as well, and the community side. So I am also doing deep dive streams now. So on Fridays, I do 2+ hours of kind of low level CircuitPython coding that I think people are enjoying as well. So lots of outreach, and at the end of the day, also the core work for CircuitPython too.
Yeah, and I also like how we're all dealing with not traveling to physical events, but we haven't slowed down at all as far as getting more people into the community. We've been using all these tools. We've always had live streaming, but the team has amped it up even more. We've been doing show and tell for an hour. You started deep dives.
Right back Desk of Lady Ada.
Yeah, Desk of Lady Ada. And so it's one of those things where once you get momentum and like a weekly schedule and there's enough interest and people can see their work. What Jepler was saying. So thanks for doing that too, because it's just as important and as interesting as pushing out code is getting new people in to then help also push out code.
Right, like multiple people will always be able to do more than a single person. So there's definitely that like figuring out that balance of like bringing more people on board plus doing stuff myself, and most of these folks here have been brought on after me, so it's working.
Yeah,
that's right.
All right, thanks so much, Scott, and we'll be asking you some questions very soon about CircuitPython. All right, Dan, who are you and what are you up to at CircuitPython?
So I'm Dan Halbert, and I've been working on CircuitPython for just a little over 3 years now. I was kind of, I guess, the second full-time person to come on after Scott. I met Scott and I was doing some bug fixing, but not working for Adafruit, and then I switched to working for Adafruit. And so I did a lot of the core work to begin with, a few kind of helper libraries, and then when we started working on the Nordic NRF chips, I did a lot of the original implementation of the core work for that. and then added a BLE, that's a Bluetooth Low Energy module. And so far, I've implemented this module 3 times. Once on the NRF, once on host computers like Windows, Mac OS, and Linux, using something called Blinka underneath. And then I'm just finishing up an implementation for ESP32, which also can be a Bluetooth Low Energy device. So I keep doing the same thing, but different every time. So it's okay.
Yeah, but you're like master of Bluetooth.
Yeah, well, Scott has done, he significantly changed the API that we had and sort of cleaned it up, which is good. I was kind of following a straightforward trend, and he made it more declarative, which was a good thing.
Yeah, Bluetooth it's so complicated. I like the extra thing we started. I said it's so complicated, only one person can do it. It's very difficult to split the work between people because of the complexity. You have to have one gigantic brain to hold it all together, and your brain can handle it.
It's not right. I have to look at this 3,000-page spec sometimes, so that's what I'll say.
Someone else here.
All right. Well, thank you, Dan.
Okay.
Thank you so much, Dan.
Rocking the fashionable AdaBot shirt too.
All right.
Yeah,
Colin.
here we go.
A lot of people know you from Colin's lab. We work together at Make, but what are you doing now, and what type of CircuitPython stuff have you been working on?
No, you're muted.
We could do Colin charades.
Yeah, we can see you, but we can't hear you.
We'll come back to Colin. So Colin, if you can hear us, you're on mute.
Okay, we'll get back to you. I like how it just kind of keeps going. All right, well, let's go to Melissa and.
All right, Melissa, unmute your mic and what you got going on?
There we go.
Yeah.
Okay, I am Melissa, and I started contributing to Adafruit with both Arduino and CircuitPython stuff kind of throughout the beginning of last year. And I started with the RA8875, writing a driver for that. And that was kind of like my jumping into the deep end for CircuitPython. And I fixed a few bugs. And then I started taking on some more things like writing some of the display I/O drivers, which was mostly just figuring out the initialization codes and stuff to get them working. And I started working for Adafruit part-time not long after that, and I did some of the Blinka stuff, and I kind of started learning with adding a new board, and I've helped other people add some boards to that. So I kind of maintained that, and now I end up doing a lot of either display work or Blinka stuff because I enjoy it.
You're also really good at it. Yeah.
Thanks.
Melissa's really taken on Blinka support, which is not only our mascot, but our Linux, single board computing, and also desktop CPython computing compatibility layer for our libraries, we just solved a problem that I had for many years, which was I really, 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 really did not want to support both Arduino drivers, CircuitPython or MicroPython drivers, and Python, like CPython drivers for all of our breakouts, because we have like 500. And it's like, it's not like 3 times as many libraries. It's like exponential. Like when you do 3 different platforms, it's actually 8 times harder, rather not just like 1 times harder, because you just have to synchronize everything. And so doing that has been just a real blessing because we can support not only these microcontroller boards, but also like 50 different single board Linux computers now, from Raspberry Pi to BeagleBone to Onion IO to Banana Pi to other fruit-based pies and beyond.
Yeah.
All right, cool.
Colin, do you want to try to give it another shot before I go to Brian?
Are you hearing me?
Yeah. Hey,
oh, well, that's always a bonus. Well, and I brought a cat. I was really just waiting for the cat. Basically, like I'm playing the role of Jim J. Bullock here tonight, I think, because I write apps at Adafruit and I make videos at Adafruit, but really when it comes to CircuitPython, I'm a fan and I'm a user, and I've been lucky enough to see this whole thing start from the ground up. And I've been in these remote meetings that you've been talking about, and I've seen you guys all work together and make this thing, which has grown really big. And I've really been happy to see that, and I've gotten all the inside scoops, and I've seen what's coming, and I've now reaped the benefits of what you made, and thank you. So from a user perspective, I speak, and I enjoy it, and if I can lend that perspective,
that's right.
Please.
All right.
I've made a lot of stuff,
Speak for
mostly music
trees.
stuff, and it's grown a lot.
Right on.
Thanks, Jonathan.
Okay, and Brian, what are you doing, and what are you doing with CircuitPython?
Hello, I am. Well, what am I doing? All kinds of stuff. It's too long of a list to mention. But for CircuitPython, my main responsibility is writing drivers for new hardware and old hardware as well. So yeah, I write the Arduino drivers and the CircuitPython drivers. I also do product guides for new products that are coming out. I do, forum support, Discord support. You name the honeypot, I've probably got my thumb in it at some point in time.
Big thumbs. It's amazing.
Yes, 10 thumbs up. So yeah, that's pretty much what I do. In my spare time, I just do the same thing I do over hacking on hardware
But with keyboards.
Yes, all keyboards. Yes, keyboards. I've got my 3D printer torn apart because I'm replacing the board. The list goes on.
Yeah, drivers are an incredibly important part of the CircuitPython story. Very early, Scott and I, talked a lot about how are we going to be able to support all the sensors and devices that we wanted to be able to, and how to create the APIs that make adding drivers really easy. Because again, I did not want to support, drivers and have it be really difficult. It's just doing it under Raspberry Pi was such a challenge, and we did it. But I wanted something that was portable and easy, and so when we drafted the API for hardware interfaces, we thought about a future Brian and like what would make things easy for Brian.
Thank you.
So, so some of the things like the registers and the bus IO library, which we then backported to Arduino, because I found it so handy. I was like, I want this on the C side. That's been really helpful there as well. So I think, we have 250, 300 different drivers for sensors in CircuitPython, and that's powerful. I think that's what, when we were covering Arduino as it was coming up, that was really important. It was the first time that you could actually get a display or a chip and a microcontroller board, and there was some chance that you could get the two to work together.
Yeah.
Because when I was in school, it was like you just got a data sheet, and it was like go F yourself. Like, good luck. You have to write the complete driver from scratch with no reference documentation other than like a really crummy Xerox of a data sheet. And now it's like people can buy sensors they buy from us, but they also buy from, eBay or Amazon or other companies, SparkFun or Seed, and then they just work. And it's like, that's so cool because instead of messing around with registers, they're building their robot, they're building their xylophone, they're building their art project.
The difference between when I first started doing this type of stuff, where I was doing assembly for maybe it was the AT-Tiny or something, versus having to figure out how to wire everything up, not knowing if I got things wrong. That compared with now, where I can buy a STEMMA keyboard, a cable, a microcontroller, plug them all into each other. There's basically no way to do it wrong, and then go to a guide and read how to use it. It's like it's insanely different. There's order of magnitudes, probably more people that are going to be able to say, oh, I can do this, right? Which is, I think that's quite an achievement.
Yeah.
All right. Well, I was going to ask Lady Ada, what were you looking for when you were thinking about some type of scripting, Python-like language when we were running into Scott? Scott you were working on your own company. I think it was Chickadee Electronics, and you were in the
making drone stuff.
You're making drone stuff, but you were asking really good questions during one of the Deaths of Lady Ada's, I think, about testers, and I think we had just started talking about we need to move towards where that everyone likes to quote Apple, Steve Jobs, Wayne Gretzky, skate where the puck's going to be, but with technology and with electronics, we knew that there was going to be fast enough chips to run all sorts of things, and what decision. But that's where that's what I was going to ask you about, because you have to do an intro for you.
Yeah.
Is what are you doing at Adafruit, and like where did this Python or scripting language for microcontrollers come into play?
Yeah, so I'm lead Ada. Hi, this is my fault. And so I own and run Adafruit and do a lot of the hardware, and Phil, of course, helps a lot too, Mr. Lady Ada. And you know, Adafruit's now like 15 something years old. When I started, it was well, first when I started, there was no Arduino. There was actually like you just wrote your code in AVR GCC and you compile it directly on, and you used a parallel port to burn chips, and that was okay. And then Arduino came out, and then it was really a great idea, revolutionary, because it was a low-cost, standardized way of connecting hardware. I remember at the time I was explaining to engineers, saying, like, imagine if you didn't have printf in every platform. It's like, what if there was actually no way to print to the like output? And you'd be, well, how? Then you could write code, but you would never see what was going on. Well, that was how microcontroller programming used to be. Like, it was done blind. Like, you barely had any way of telling what was going on. And so when Arduino came out with like a built-in serial port, like debug output, it was like really amazing, because it was so obvious, but like nobody had done it. Like, you wouldn't get dev boards with serial port access. It was just like you just got pins and like 3 LEDs and like, you know, go after yourself. So when, you know, we were doing Arduino for quite a while, and it was really good. As projects got more and more complicated, though, I noticed that first off, it took a long time to compile stuff in C. Just C compilers take a while. You know, GCC is not the fastest compiler, and iteration was challenging because of that. You'd have to do this like compile, upload, read the output, see what's going on, debug it, and cycle again. And this code loop of writing code, uploading, like compiling it, uploading it, debugging it, was way faster than it used to be, which again was like, you know, you'd have a firmware program, you have to remove the chip, you have to put on a UV lamp. So that was like, you know, 20 minutes per cycle, but it was still a couple minutes. And I thought, like, it would be really nice if it was much faster. And I started seeing people start to do it, you know, this embedded microcontroller programming language stuff like Espruino and MicroPython. But at the time, I actually was, you know, we looked at it and I was like, well, I really wish it would run on the SAMD processor, because we were already using that chip with the Arduino core so much. And it was a good chip. It was like, you know, it's low cost, has a lot of great peripherals. I was comfortable with it. I knew the Atmel chipset really well. And then when MicroPython was basically ported to the microbit, that's when I knew it was possible, because until then it was always like on these, you know, STM32 F4 series, these very kind of high-end processors, which would have run on the Arduino Due, but I didn't like the Arduino Due chip for like other reasons. And so when the microbit came out with MicroPython, I was like, oh my God, that only has 16K of RAM. And if 16K of RAM can run it, then the SAMD21, which has 32K of RAM, can definitely run it. It's like twice as much. And so, you know, this kind of, you know, I was kind of thinking about this for like half a year or a year. And then MicroPython came out for the microbit. And then like a couple months later, Scott was coming on the show and tell and talking about the SAMD21 and doing this development board. And he started talking about like, oh, I'm using like Atmel, like ASF. And I was like, oh, okay, like you are willing to like deal with this bullshit. Because like the problem is that like I actually have been trying to get some engineers, I was trying to hire engineers or find an engineer who's willing to do that low level work. Building a board support package, it's really like, it's good work, it's solid work, but it's really unpleasant. There's a lot of like annoying details that you need to have someone who's just willing to stick with it, because it's not a project that can be, you can get something going in a week or two, but to actually get it working takes like 6 months. It doesn't take any less. It's a six months, 9 months, a year to add a platform to any new development system. That's just like a time constant. So that we started with the SAMD21, and it was really fun. Like I remember when I got the Raspberry Pi, and I remember like, you know, I got one, it was like the first Raspberry Pi, and I plugged it in, and you were like, you kind of like were like, well, what do you think? I mean, what is this thing? This was like the first week of it out. And I remember like I was messing around with it, and I was writing Python code to talk to hardware on the Raspberry Pi, and they turned to me and said, this is actually enjoyable. And I had, so that reaction was like, there was like, this is actually enjoyable. I'm actually having fun writing code. Cause like, I don't like, I have like a biological urge to write code, but I don't enjoy it. And I have the same thing with CircuitPython. The first time I sat down and wrote CircuitPython code, I wrote a game of life on an LED matrix, and I was like, wow, this is actually fun. I'm not dealing with pointers or memory or stir. Somehow stir is always in every freaking project for some reason. And everything's very fast to iterate. And I was able to get the project going in 15 minutes. And to me, that was really amazing that it was just so fast and enjoyable. It was like a pure coding experience without the unpleasantness that I would have when writing a lot of C code.
All right, so that's a good overview. So what I was going to do is I'm going to start with Scott and then give everyone a little bit of time, because I think Scott probably will have the answer to this question on the tip of his tongue, and then everyone else have a little bit of time afterwards. So there's more beginners and more people who don't know about computer programming than do. We have a long road and a lot of work to do. So Scott, when someone says, what's CircuitPython? Two-part question, and we'll go around to each person. I'll call on you, and we'll keep these kind of fast. So how do you explain what CircuitPython is? And then what project do you normally point people towards? So everybody else, think of your one sentence how you describe CircuitPython, but also think about the project either you did or one that you would point people to as a pretty good example of oh yeah, here's a good example of what CircuitPython can do. So Scott, what's CircuitPython, and what's a project that people should take a look at?
So I usually call CircuitPython Python for low-cost embedded computers called microcontrollers. It's kind of my spiel. It's very easy programming, I guess I would say. I don't actually have a single project I point people to. I just point people to the learn.adafruit.com, and I tell them to scroll through it and see what catches their eye. See what they want to make, and then go from there. I don't have a specific one that I point people to.
Yeah, I think when we had a handful of projects, it was easier. It's oh, here's one that plays music and does a light show. We have drives NeoPixels, but now there's hundreds of projects with 2,000 something guides.
Yeah.
Okay, so I'm gonna do the square tour here. Kattni, how do you describe CircuitPython, and what's a project that you point people to if they want to get started with it?
So to me, CircuitPython is a way to use Python coding, but to interact with the physical world versus interacting with data. And that's really what hooked me on it in the beginning. I tried to learn Python before I found CircuitPython, and I couldn't get into it. It was boring. But the minute I made an LED blink was just, everything made sense. In terms of projects, I like to find out what people are interested in, what they want to make, like Scott was saying, or what it is that they want to do. And then I try to find something similar and point them to that to give them inspiration. So there's not really a single one that I point to either. It's more about getting people to think about what they want to do and then helping them with that idea.
I also like to send people to Kattni's Key of Line project. It's a great guide.
Thanks.
Next up, Anne.
Anne, how do you describe CircuitPython, and what's a good project for people to check out?
I really steer people towards the fact that it's been mentioned, you can focus more on your project and not necessarily on all the little bits of machine language code that you need to do it. Everybody can think of a project. They want to do a robot. They want to do blinky lights. There's any number of, I want to do this. And so many people give up when they get to a platform. They choose one, however they do, a friend recommends it or they see it on a website, and they quickly start reading into it and see how hard it is and give up. And I really feel that that's a disservice. Making is all about accomplishing things, being able to do. And CircuitPython does that because it takes down those barriers. Python's being taught more in schools. It's a requirement in some countries to learn Python. It's very easy to use. And there's things like the REPL that Lady Ada has talked about, where you can just go in and start typing things and see it actually work. So breaking down those barriers and say, okay, I don't have to worry about a driver or connections or something, because a company like Adafruit or others have already gotten that down to a standard. So I can focus more on, will my robot have a vision? Will it move? Will it do something else, rather than focusing on making it move an inch or two, all the complications in that. And as far as what I like, I mean, I will make a little pitch. I mean, I did write a book on the Circuit Playground Express, and I put in code for how to use it. And Arduino, I couldn't even fit it into the size of the book, but CircuitPython, you can get up and going very quickly. And so there's a number of guides that you all had me write that do that. If you go to learn.adafruit.com, there's the Make It series. My favorite there is Make It Move. So you can go onto that free tutorial and learn how to have a microcontroller talk to something like a Cricut motor thing that's just, they fit together, and there's libraries that just make it work. So you learn, motor move forward, and it goes. And you've done what 5-10 years ago would have taken an electrical engineering student a quarter to accomplish.
All right.
Right.
Thank you so much, Anne. All right, Jepler, how would you describe CircuitPython? What's a good project to point people to if they want to get started with CircuitPython, you think?
So I'll answer the second one first, and that is the things that have just filled me with the most joy to look at are some of Aaron St. Blaine's projects with LEDs. I think anybody can instantly connect to that and imagine a way that they could take that and make it their own.
Like, I want to make that, I want to do that, and then that's the motivator to go learn. Because you have to see it. You have to be like, I want to, cosplaying, of course, it's now, remember when it was like, oh, this is an interesting hobby. Now it's like, all we are is a bunch of Marvel movies now.
Yeah.
And so, like really, like that's our currency with a lot of how we even interact with each other. It's like, what science fiction things do you know about? Do I know about? So I think that's a good example. Like, people see Aaron's projects, they're like, whatever that is, I'm going to learn it. Whatever that is, I'm going to do that.
But then also to echo Kattni and Limor, when you work with Python and you're working with hardware, it can just create this joy in you, and it's meaningful in a way that working with maybe just Python on a computer is. I've talked with people who've done like a code boot camp or a data science approach to Python, and they bounced off because it didn't connect with anything that they really cared about on a personal level. And when you bring it into the physical world, if it's a display, if it's a sound, if it's a motion, you really connect with it, and it creates an experience that you don't get just coding on a computer that stays inside the screen.
All right, good answer. All right, Dan, what's a good explanation of what CircuitPython is when you're telling people the elevator pitch, the 2-sentence thing, and then what is the project you point people to?
So I agree with what both Jeff and Kattni said. That I just say it's easy programming for physical computing, and then I have to explain what physical computing is. But it's like controlling real life things, and so much programming is like limited to these flat screens that glow, and the examples are all about that. So normally people write a Python program, maybe it does some graphics thing at most, or maybe it just makes change. That's how they learn it. And it's like it's connected to their sort of daily phone experience or something, but it's not real life in terms of the physical world. And to be able to control the physical world, things that are kind of magical, like you don't really know how a car works. Once you know how a car works and you know how to like fix a car even in a limited way, it really opens up your understanding of things. And I think the same thing would be true for doing something like CircuitPython.
You were working on an accessibility project that was like switches and buttons and knobs and foot switches for a friend of yours.
Yeah. Yeah, that was and CircuitPython. It happened to work out really well because of some features of it, like the CircuitPy drive, which made doing the project much easier than doing it in Arduino. It made it configurable. It made it like programmable by my friend. Not necessarily that he would write CircuitPython code, but that I could say, just edit this file, and you can change what buttons that you are operating with your feet do. And in terms of the projects, I mean, what I've seen is that if you just give people the REPL and say, here's some simple code examples, type these into the REPL, touch, and make NeoPixels go and turn a motor and that kind of thing, then people get an idea. It's like then they come up with their own project. And so it doesn't really matter like what the initial project is, as long as you give them 4 or 5 things they can do, then all of a sudden they'll leap into doing something. I mean, I was helping some a Girls Who Code group. They weren't using CircuitPython, but they were doing MakeCode, which is kind of one step easier. But all I did was just show them the things that they could do, just like I would have done in CircuitPython. And then each of them came up with something. Oh, I'm going to make something that plays music. Or I'm going to make something that does lights. Or I'm going to make something that responds to movement. And so each of them immediately came up with something that they really wanted to do once I showed them the building blocks. And you can do that so easily in CircuitPython with the REPL.
Right on. Yeah, when we were trying to help make robotics more accessible, being able to iterate with a REPL and turning a servo motor so you can get the robotic thing to do exactly what you want, and doing that over and over and over again without having to compile, because you're just like typing in values. You're like, oh, I want it to go this much, this much, this much. You can actually see real time a physical motion of the thing that you just typed in.
Yeah, it reminds me a little bit, of talking about how you were showing all these kids the different tools. It's a little bit like art class. When you're a kid, you go into like art class and there's like paints and there's clay and there's, Fimo and there's like paper and scissors, and you're not told what to make. They're just like, why don't you make something with the materials? And it's like no kid is like, I have no idea what to make. They're always like, they just grab whatever and they just start making, and they're inspired by the material properties.
Yeah.
And I think CircuitPython has a little bit of that. That the properties of the electronics are more tactile, they're more available to people, because you can just write in the REPL what you want it to do.
You could play.
Yeah.
That's right. I mean, calling it the Circuit Playground is actually, I mean, you're playing in the REPL. That's why it's so much fun. I mean, adults have more trouble doing that. You're saying kids, they just say, oh, this is what I'm going to do. They don't have to get an assignment. Adults have more trouble with that, but sometimes.
All right, Colin,
okay.
How do you describe CircuitPython, and what project would you point people to?
I guess I have described it as programming electronics with common sense, more just to really break it down kind of thing, which the common sense I mean is really dragging and dropping files is a really big thing. That's a modality we all know, and like kids know, and my parents know, and my brothers know, everybody knows. So you can jump right in and realize that, yes, you do know how to operate a computer, and that is a technical thing, and you don't have to jump through all these other hoops. I myself did learn to jump through a bunch of other hoops, and when you guys were first showing this work, and I'm like, I don't know, scripting, I don't know, what is drag and drop, whatever, I'm going to compile, I don't know. And obviously I really warmed up to it over the years, and yeah, I think that's a really important bridge, and even if you are used to older ways, when you go to this, you can free up some brain space to focus on what's more important. As far as a good starting point, I mean, come on, NeoPixel strand test. That's the inroad. That's the classic, right? And you get that instant light up satisfaction. And then my personal favorite is the Feather waveform generator project by Dave Estells, because you got an encoder working in there, you've got an OLED, and you're generating audio, and it's like all pretty compact and really understandable. So a little bit of a step up.
All right.
All the spectrum, really.
Melissa, how do you describe CircuitPython, and what's a good project for people to check out?
I would describe CircuitPython as a language that you can use to concentrate on what you want the program to actually do instead of all the little details like the data types and everything. And the projects that I would point people to are the ones that would inspire them, really, because I've had the most fun on projects that I have been inspired by, and it's like I just can't get certain things out of my mind. Like I had done a calculator that I put a Raspberry Pi inside of, and that was a lot of fun. And I've done like a message reader board, and I like working with a lot of the displays with CircuitPython, and I always just find that a lot of fun. So it's just really whatever inspires you.
All right, Brian?
I like to tell people that CircuitPython is a way of telling the little computers in your refrigerator what to do. Because that's like, if you start with it's a programming language or it's programming, a lot of people don't even know what that is. But one thing that's cool about CircuitPython is that it is accessible enough that it can be someone's first programming language. It can be a way to learn what programming is, and having it be, you know, tactile, like everyone's mentioned, is a huge part of that.
All right. Okay. Well, that's a good overview. Lydia, did you have anything before we move on to asking some more questions and then hitting some
No,
questions in the chat?
I think it's cool to hear from everybody their different insight. You know, people, you know, everyone, and I'm looking around, I'm like, well, everyone is coming to this from a different background. Someone like Anne, who's been writing code for, you know, decades, and you know, Dan, who comes from a Unix background, and Kattni, who learned to program in CircuitPython, and Scott, who, you know, wanted to do a hardware company, and then, you know, I think probably wrote the code in C, and Colin, who came down to Earth from his native planet and brought us musical synthesizers. You know, and Melissa, who's really into displays, and Brian, who's really great at writing grabbers, and Jeff, who is a jack of all trades. You know, everyone has their own way of contributing and being part of it, and I like how there's a little bit of overlap, but everyone really does have a unique way of using CircuitPython and contributing to CircuitPython. The way they look at it is a little different.
Yeah. You know, one of the things that, because we have a large customer base and a large community, and we also have a lot of employees, one of the ways that you end up describing something like CircuitPython is it's always helping you. It's always doing things. It's like someone put a lot of thought into it.
It's not a mean language.
Yeah, it's every opportunity. It's like, oh, look, it's giving me a message that's helping me. So I always start with, well, when you plug in that microcontroller, that electronic, whatever it is, it just shows up as a USB drive. That's something that everyone knows. So everyone knows, like, oh yeah, USB drive. Like, I use those all the time. It's something helpful. I'm putting something important on it. It's mine, and I'm going to do something with it. So there's a physical nature of it. It's like, well, what if computer programming was as easy as plugging in a USB drive? And that's like, ooh, tell me more. And then you start to get into things like, well, what are things you like? And if you like music, there's something. If you like visuals and having lights light up. But one of the things that I suggest is I always point people to some of the science fiction or cosplay stuff. It's like, oh, you know that tricorder that you always wanted to make? Oh, yeah. Because it's a lot of
people making like the lightsaber props.
Yeah.
Like a lot of people who want to make lightsabers, and I've always had a bit of a nitpick with the lightsaber building community. It's so complicated and expensive. I am sorry, like, if you're watching, but I've always been like, why is this so complicated?
They're not watching, they're working on their lightsabers.
And you know, it's nothing's open source, and it's all just like proprietary. And so I was like, let's just make it really easy to do, like light sword or ray gun props. And it's like, it is really easy. You can drag and drop the sound effects. You can change the light colors of your lightsaber very easily. All things that are just like so hard to do with straight C programming.
Yeah, so that's usually what I try to do is I find out what they know that's familiar with, that they're familiar with, and then talk to it about something they want to do, or like, hey, you know how like it's always annoying to do the following? Well, it's not, and this makes it easy. You don't have to do that. Okay. Well, I want to maximize our time because we have about 15 more minutes. We'll get to some questions that came in the chat, but let's do a little bit of a speed round. I'm going to start with Scott again because Scott steers a lot of the CircuitPython ship, and then everyone has a little bit of time to think ahead. So, Scott, the next year, because we're going to look back at this CircuitPython day, what do you want to see in CircuitPython over the next year? Yeah,
I have a non-answer, kind of. I want to get Colin sucked into CircuitPython land. He started working on Glider, which is a prototype I did a year or two ago, but it's core to my vision for what CircuitPython broadly means, which is making computing more accessible to people as a tool to do whatever they need. And Glider specifically fits into that in giving people access to programming when they do not have a laptop, do not have a desktop, when they only have a phone with a touchscreen, having a reasonable, fun way to get that same CircuitPython experience we're talking about with USB, but over Bluetooth from an app on your phone. That's not in the CircuitPython core. I've got lots for that as well, but you know that the core goal, I think, for Adafruit and CircuitPython as a result is bringing more beginners into programming.
It's a perfect
and
fit,
I think that it's my dream. It's complicated. It's R&D, but that is core to our mission, I think.
Makes perfect sense. And stay tuned. Already started out. You sparked my interest heavily, and it's inspiring to take on the fly, and then maybe you're gonna put it even more on the fly, and be able to change your NeoPixel colors at the con while you're checking out, buying your wings.
Yeah,
it's really innovative stuff.
It's a great vision.
Kattni, between now and next year, what would you like to see in CircuitPython?
I would like to see it become even easier for community contributions to be made. We have a community bundle for libraries from community members for stuff that we don't necessarily support directly. We've kind of made it easy to do, but it's not. There's a kind of complicated guide that you need to follow to a T and like update some stuff to make it work and so on and so forth. And I want to see it where someone can say, I wrote this thing that works with this board that I bought, and I think it would be great for CircuitPython. And we can say, all right, go here and do these 3 steps, and then we'll get it added to the bundle. I want to see that streamlined because community contributions are super important to what we do. The community is core to CircuitPython. And I want people to be able to be more involved without having to know a lot of ins and outs of various things. So that's what I would like to see.
Yeah. Having like a robot automatically pilot, it'll be like, hi, Databot coming in, like getting your library all ready for submission.
Yeah.
It's like sweep it up.
And I think it shows a lot of, confidence that we have. Like, we're working back from the idea that this is going to be really successful, and we're going to have to manage a lot of different things no matter what. So why don't we start and make it easier long term? Like right now, we build thousands of firmware blobs to get it onto all the devices, different languages. We thought that was going to happen from the start, so we did a lot of work with it. So it's a good future thing. We'll see how we end up a year from now. Anne, what do you want to see in CircuitPython over the next year?
Well, I was just thinking that we've all been very challenged in the last few months. Adafruit has been working very hard as far as COVID and all the related stuff. We now have millions of students who are separated from their classroom. They don't have a classroom full of laptops or computers or something. It would be good to keep the new learning paradigm in mind when we're doing this. And as Scott was just talking about, maybe people don't have certain types of computers, but nearly everybody has a phone with a USB port, or nearly every phone has Bluetooth now, Wi-Fi. So to simplify that to the level that Kattni and Crayola have done with taking LEDs and going from I can light one LED to I can light a whole wall full of them. If we could kind of translate that into the communication.
Okay. All right, Jebler, what do you want to see in CircuitPython next year? Is it CAN bus?
I mean, yes, I want to see CAN bus hopefully in the next month to 6 weeks. But within the next year, I mean, I just keep getting pulled in new directions with everybody's ideas. But something that is on my mind a lot is this act of getting the libraries onto your device. You know, you'll go through a guide and it'll say, you need this library and this library and this library. I think there is a really ripe spot, especially with the ESP32S2 with the Wi-Fi coming on board, for somebody to come up with something that is really disruptive and awesome in terms of getting the supporting code that you need onto your device. And I don't know what that is, but I hope that somebody will see what that is and come forward with.
Yeah, and we'll do a little bit of a top
that we're
secret coming
waiting for.
soon. So this is a clue. This is a microbit shaped board, runs CircuitPython, has a screen, and this is the ESP32S2 Mini, which happens to fit exactly on the back. So now we're going to have a Wi-Fi clue. So I'm going to go to Dan in a second, but you can imagine a hardware world where everything's low power, everything's Wi-Fi or Bluetooth, everything has a screen, everything shows up as a USB drive and/or easy to code on a phone or whatever you have, and it's like $20. So think about what that means for education, all the way to helping a sensor everywhere in some way, that you have like real-time feedback, battery, portable. And
I'm not going to be happy until the clue board actually, when you turn it on, it says it's time for an update, and it takes like 20 minutes to update itself.
Yeah, it's like my next thermostat. All right, Dan, what do you want to see in CircuitPython over the next year?
I think two things. One is something that Scott asked me this morning, and making doing things in parallel easier. Like, I want to control several NeoPixel strands at once, or I want to listen for some inputs and also do some outputs at the same time. And can I do that simply? There are ways to do it right now in regular Python, and they're really complicated and they're hard to understand. And it would be nice to come up with a programming paradigm that makes that easy. We see that in some other systems like MakeCode, and can we do the same thing in Python? And then the other is to make more building block libraries so that it's as easy as possible to do a simple Bluetooth project or a simple Wi-Fi project. So that a lot of the stuff that, just like CircuitPython hid a lot of the hardware details, can we also hide a lot of the programming details underneath the libraries?
Colin, what do you want to see in CircuitPython?
Okay.
Well, I definitely like the second, what Jeff said about, like, there's some magical thing that fits into the library loading deal, because it pretty much, once you've, brought down friction in all these other areas, then there's the couple little peaks standing there sort of stand out. And I'm like, how did it get, that seems, maybe I'm getting lazy. I just want it to happen automatically now. And then, of course, like Scott said, mobile code editing is definitely in our future, I think I can say for sure. But I'll leave that for another time. As far as what my brain just wants to see besides those two things, to add to the conversation, I would love code completion just in an editor. And Moo is great because of its simplicity, and perhaps I'm a little spoiled by Xcode, but I'd love something like that. And I know that was a great reduction to the barrier for entry when I was getting started coding. And just as a bonus, there's a lot of documentation. I was going to say I want more documentation as a reflex, but there's so much documentation, it's really good. So thanks for that.
All right.
Thanks, Colin.
Okay, Melissa, what do you want to see in CircuitPython over the next year?
I would like to see some more UI controls that we could be adding to, like, the PyPortal and stuff like that, like radio buttons and scrolling text boxes and things like that. And I'd also like to, this is more of a dream, I guess, that we could have multi-threading in CircuitPython itself. So, because there's definitely been some times where I would have liked to had a thread running in the background and stuff.
All right. Brian, what do you want to see in CircuitPython over the next year?
I have a short attention span, so right now I'm thinking about motors a lot. So more support for drivers-wise and hardware-wise, stepper motors, brushless motors, encoders, things that work on robotics projects would all be cool. Everything that everyone else said is a way better idea than that. But
No, I know people like most CNC projects would really benefit from Python.
yeah, I mean, it's starting to get more into the 3D printer kind of hardware space. It's there's, I don't know, the way it's done now, I feel like there's a lot of room for improvement to make things easier. Not necessarily CircuitPython, but whatever. But I think specifically making things easier for people in general, whether it's documentation or you know, doing PRs or like just learning how to program, all of that stuff is really good for, I think, empowering people and showing them that they can do these things that they thought maybe they couldn't. And I think in general, that's a good approach to kind of have, is keep doing what we're doing, growing our user base, making it easier. And yeah, making it easier to do a PR would be awesome. Because like compared to everything else in CircuitPython, it's like, okay, I guess I can go up there, but do I have to?
Yeah.
So, yeah.
Yeah, a lot of the emphasis that we'd like to do over the next year is just not necessarily CircuitPython related, but we still want to do the GitHub for Kids approach, where like on the like a very like Lego-y, easy, my first like GitHub thing. And one of the ways, you know, I remember I was older, but making an HTML website on your own from scratch was like a big deal.
Yeah.
And it was like, make sure you learn HTML. And I feel like GitHub pages, even if you're just editing a README, you're doing an about page about yourself. And GitHub, now that they're part of Microsoft, you could definitely see that as an emphasis. So I think one of the things that will be good is being able to get more people, even if they're not necessarily writing code, but they're updating things, they're doing things just to get into the habit of it. You know, the future is, a lot of the things we're going to be doing is manage code together and social coding in some way.
Yeah, and I think, you know, I know that, you know, the way kids do homework assignments now is it's all done online, submitted online, it's edited online. So the idea that you have like documents that people are looking at and editing and like live, and you can see people editing. To me, it's still magical, but for a lot, you know, for anybody growing up now, it's completely normal.
Yeah.
Like they don't even like, they're like, why would you ever write something that isn't in the cloud? Like what happens if your hard drive dies? And it's like, well, you just lost everything in your life and you just kind of dealt with it. And I think the same thing's going to be for coding. It's like, what do you mean you would write code on your own for your own devices? What do you mean you weren't doing it as part of a community effort? Yeah.
Before I do a little bit of a speed round with some of the questions that came in, so one of the best ways to predict the future is just to stop by Lady Ada's desk. And what's on Lady Ada's desk, and we talk about it on Desk of Lady Ada, the Wi-Fi is getting tiny and it runs CircuitPython.
And it's cheap. It's like probably going to be $1.
And we have e-ink displays that are full color or lots of colors. We're doing low power stuff with CircuitPython. Things will be able to turn on and turn off, get code updates, be updatable, open source. You'll know what's in there. I think a lot of people care about privacy. If you can look and inspect the code on these devices, you can improve it, and also other people can improve it. And I think that's one of the things that's really important. When we make an IoT device, we're like, let's make sure there's an off switch on it. So let's do a little bit of a speed round with some of the questions that came in. I'll also read off some of the compliments and more. A lot of folks really like the maintainability of CircuitPython. So one of the questions was, is CircuitPython stable enough for commercial applications? And is there any over-the-air firmware options available? I can answer the first part. So we know people are using this in a commercial setting, but not because of the ease of update for firmware, you know, wireless updates. It's because it's actually maintainable. You can deploy a bunch of things, and you can do you can do something to it. It's not game over. You don't have to recompile. You don't have to do everything. You actually have the ability to do stuff. So I guess does anyone want to take on the second part? Do we see an over-the-air type firmware delivery method, or for libraries at some point in the future?
So we are trying to figure out the final partition layout for the ESP32S2, and we do leave 2 spots for CircuitPython, so that one day you'll be able to do that. But we don't have any concrete plans to do it. We just don't want to like preclude it from happening later. It'll basically probably be like supervisor dump binary.
This little ESP32S2, it's Wi-Fi, it's going to run CircuitPython. We have USB, so expect it. Like it's not a question of if now, it'll be when we do things like that, because we just have like a low-cost Wi-Fi chip with all the power of Circuit. Python. So we'll definitely use all of it.
Yeah.
Yeah.
We're thinking
We're not doing
about
it now,
so that
but
we don't
we'll
get
do it
stuck.
sometime in the future.
One good thing for the person who asked about the commercial application. So
Exactly.
one of the things that we have seen is people who have deployed something that, like it's a data logger, for instance, they're USB drives. So when they take them from the field, they just plug them all into a hub and they show up as USB drives. They can script it, or they can just grab up files, they can update stuff, and now they're back. And it's a lot easier than worrying about all the other things that you normally have to worry about for device deployment, especially for like sensors that you're getting huge amounts of data in. Next up, what point should someone consider CircuitPython for a project instead of Arduino? What are the bottlenecks to make it worth the expense? I'll help out a little bit with this. I don't think it's an either or. I think you should just look at what you want to do. And if there is an easy way to get there, pick one, try them both. And then bottlenecks.
You do need a faster processor.
Yeah.
If all you have is an Arduino Uno,
If you're still rocking the Arduino Uno, you're going to be sticking with that. But does anyone want to answer that? Like, what's the fork in the road? Not literally, but when do you say like, oh, like I would normally do Arduino with this. I'm going to go down the CircuitPython road.
I kind of think of it backwards from how I learned both. So I learned Arduino first, and then went to CircuitPython because it was around. But I think generally speaking, CircuitPython is a great place to start. It's easy to use. You can iterate really fast, get things done. And then if you ever find that it's not fast enough or it's missing some driver you care about, then by then you'll have a good design, hopefully, that you can port into Arduino and make it faster. And all that
so we'll be in the chat. We'll drop some of the links. I want to remind everyone that this CircuitPython Day and every CircuitPython Day forward, we're always going to dedicate it to a group. So this one is dedicated to Lambda Labs. They're in Beirut. Everyone saw the explosion that happened there. 2020 just continued to deliver the hits. So in our chats and in the blog posts and more, if you want to donate, if you want to help support them, they were part of CircuitPython Day from the start. And that was one of the things that we wanted to do with CircuitPython is go international. But we all know we're kind of stuck in this sliders universe for a bit. And so we're going to have to help each other quite a bit. And so in our closing minutes, I'm going to go around starting at Kattni and I'll weave through. You're going to probably look at this video a year from now. If you could tell yourself something, a year from now, Kattni, what would you want to hear yourself say? Like you're now going to be talking to someone, a version of you a year from now. You
also ask that person a question.
Yeah. So
that's a tough one.
I know, right?
For one thing, move my camera so that I'm actually centered on it. So I start.
Yeah.
But in terms of CircuitPython stuff, I guess I'd want to know, or in terms of telling my future self stuff, or vice versa, I'd want to know whether the stuff we wanted to see out of CircuitPython happened.
Right.
Because it's important stuff, but it's a lot, so we can't do all of it. So I'd want to know whether or not we did it and what our priorities ended up being, and whether or not we're going to put effort into the rest of those things.
Okay. And message to yourself for next year.
I would ask myself, how are we connecting with the community? I'm always looking for better ways of finding all the news around the world for the newsletter and for Adafruit social media. How can we interface? And it's been a core tenet of CircuitPython that it's not just the code, it's not the hardware, it's a community, because it wouldn't be here if everybody wouldn't be contributing open source. So I'd be asking myself, well, how have you done it better? Because I can always use
a message to the future self. What do you want to send?
I'd say future self, remember, even though there's a lot of bad stuff going on right now, that there's a lot of good stuff, and how much fun you're having with what you're doing.
All right. Scott, message to future Scott.
I don't know. I think this is kind of a hard one.
Yeah.
I think
last.
Keep working on the things you think are important, even if you didn't get them done.
Yeah.
Glider is one of those things. So I'm going to continue that on. Big things take time.
Yeah, this is a little bit of a trick. We're showing our work. So we do a show every week forever. We've been doing it for like 10 years. And so there's projects that we started 7 years ago that we might just be finishing now. And I think part of the idea is if you publish and you do things open source, you can always go back to it, but just keep the momentum up. Like just have, and sometimes it takes people, sometimes it takes resources, but there's a lot of really good ideas. Just because you don't get to them today doesn't mean they're eventually not going to happen. Like we spent a really long time on getting Feather going. There was a lot of different.
Yeah, it took a year.
Yeah, there's a lot of different things that we're like, we'll get to it. All right, Dan, what do you want to tell future Dan?
I think I want to ask or say, let's make sure that the experience gets even smoother.
Okay.
That there are fewer bumps in the road and everything kind of works, and we don't have to explain the same things over and over to people or help them with the same problems. It just works.
Got it. Colin, message of future Colin, a year from now, because we're going to look back at this.
Are you okay? Did you survive? Do you still live in a democracy? I'm going to try to boil this down. Do you remember what is important? I'll say that. Do you remember to focus on what's important? And actually, I have been doubling down and sort of realizing that over these more harder times, that creativity, connecting with people through things you make, that is what's important. And that's what you guys really make happen, honestly. So thank you.
Melissa, send a message to yourself a year from now.
Oh, you're muted.
It's a very quiet message.
Hopefully I can hit to my future self. I'm gonna say I'm sure my future self will know more than I know right now. But I actually had asked my future self. I hope my house didn't burn down in these fires.
Okay.
But
fair enough.
Regarding CircuitPython, I'm gonna say just keep on working on these projects that you love doing and enjoy doing, and you'll do well.
All right, Brian, future self, what do you want to say? What do you want to ask?
If I had 5 minutes of my own time next year, I would ask a question and make a statement. The question would be, are there machine parsable data sheets yet? And the statement would be, look at all the things you did over the last year.
Yeah.
Because I think it's really easy to forget all the stuff that you're doing on, because you're so focused day to day. You look back and there's a trail of things you've done. So it's good to keep that in mind.
All right.
Remember somewhere I read for a lot of people, they're disappointed with what they've done in one day, but they're impressed with what they've done in 1 year.
Yeah.
Exactly that,
and that, I feel like that sometimes. Some days I'm just like, I only did one thing. I just I fought with like an encoding error or something for 6 hours. I didn't even get to do the thing I want to do because I was just fighting with something. But over the long period, some days go fast, some days go slow. But over a year, we've accomplished quite a lot.
All right. So is this your thing you're going to tell yourself?
I think so. I mean, I don't even know what Earth is going to look like in a year. I'm kind of scared. I think what I would like to see in the next year, what I think would be good is more wireless and another 2 platforms added. I'd also like to see basically the default shipping firmware for I think when companies are going to come out with low-cost ESP32S2 boards, there's a lot of people making ESP32S2 boards. I would like CircuitPython to be the default thing that ships on them. And I think
they should. I mean, it'll save them a lot of hassle. I
think so too. And I think if we do a good enough job, it will become the default. And I think that's a good sign when it's like today as I was working on the INPI, I looked at analog devices and they basically, for this chip I was looking at, they didn't make it a dev board. Usually they make these $70 dev boards and it's just a whole thing just to test this one little chip. Instead, they actually made an Arduino shield and they're just plug it in. It's basically like a stemma connector, plug in the sensor and then you want our Arduino sketch on it. And it's it took 10 years, but Arduino became the default install for people doing electronics. And CircuitPython to be part of that as well.
Yeah. All right. So we're a couple minutes over, but it's okay.
You have to go.
I'm gonna say just the last thing, and I we do a weekly State of the Fruit.
Yeah.
Which is our entire company, and we have these recordings that we do internally of it. Everybody knows, I'm reading off the notes and we're doing stuff. And I know I'm going to look back a year from now and say, what happened March 15th? What happened the week after? What happened the week after? And as a company, as a culture, and this thing that we're working on called Circuitpython, which is more than just the code, it's more than just the hardware. I think these connections that we're making with each other right now, the people connections that's making the hardware and the software happen, is going to be the most special thing that comes out of CircuitPython. Because times are extremely tough. They're probably going to get worse. I usually try to live in the future. They will get better.
Yeah.
So the thing is, we're probably going to be stuck with each other. So if we can make even the tough times work out really well, they're going to get even better. We grew up Adafruit as the World Trade Center was getting built, and during the last recession, the Great Recession, 2008. And as we were building Adafruit in kind of the toughest times, that's what helped made Adafruit such a sturdy, anti-fragile, robust company that keeps all of us going. So we didn't do any layoffs, no furloughing, no cut hours. We're able to carry and sustain people better than giant publicly held companies, venture-backed companies. We've been a woman-owned company manufacturing in New York City. So I think the investment that we do in each other and in the community, and just taking good care of ourselves and getting used to the idea of like, let's always publish something, even if we don't think we get everything we want to get done each day. Just chain together a series of good things, even if it's just something once a day that we can look back on. I think that was mentioned before, like look back, because that's the thing that'll probably help continue to get us through, because that's what got us here.
Yeah.
That's why we were able to like.
No, you're relentless. You do something every day.
Every day you have to do a little something. And with the things like helping people get ready to vote, helping mobilize our team from racial injustice to getting the word out to vote, to helping people remember to wear a mask. Like if you do something, just one thing each day, whether it be something with code or something with our community, you can chain all those together. And that is what helps make things better.
Yeah.
It's not just one individual, it's just a bunch of people every single day doing one thing that moves us forward. So that's the thing I hope we can all look back and say, yeah, you know what? Like that was a tough 2020, but boy, look at what we did.
Yeah.
So, okay, with that, we'll see everybody. That is our CircuitPython day.
Thank you, everybody.
We'll look back at this next year. Thank you, everyone. Thank Kattni, Ann, Jepler, Scott, Dan, Colin, Melissa, Brian. Don't forget, this year is dedicated to Lambda Labs. Look for the links. We do this every single week in some way, shape, or form. Check out our Discord meetings that we have on Mondays, normally at 2 p.m. Eastern time. Check out our show and tell that we do starting, we're going to move it to 7:30, not a full hour. Starting Wednesday of next week, Ask an Engineer, 8 p.m. next week. Deep dives with Scott on Fridays. We have JP's new product pick on Tuesdays, and then JP's workshop on Thursdays. And Noah and Pedro have their show, 3D Hangouts. So you can do something every single day with Adafruit if you really want to. Or you can catch up later and just binge watch us all on the weekends.
And you can always join us on Discord.
All right. Thank you so much, everybody.
Thanks, everybody.
Have a fantastic CircuitPython day. We'll see everybody tomorrow, and do one little thing that makes the world a little bit better. It might just be up to us. Bye,
Bye, everybody.